I am the Optocoupler Product Manager for Broadcom Isolation Products Division. Thanks for joining my presentation today on driving silicon carbide and gallium nitride power switches with Broadcom Optocouplers. This is today's agenda. I'll begin with a brief overview of our optocoupler portfolio. This will be followed by driving silicon carbide and GaN power switches from Infineon, Wolfspeed, STM, and Xperia using Broadcom Optocouplers. Broadcom has a wide portfolio of isolation products from digital to gate drivers to current and voltage sense. In today's presentation, I'll focus on the new 10 ampere gate drive optocouplers and how they can be used to drive silicon carbide and gallium nitride power switches. Before I start, let's have a watch of a short video of this 10 ampere gate driver. Hope you have enjoyed the video. Next, let's look at the first design, driving Infineon Dual SiC module. Mounted on the silicon carbide module is the driver and sensing board. Two gate drive optocouplers ACPL355JC are used to isolate, drive, and protect the silicon carbide power module. Two ACPL-C87B are used to measure the DC bus voltage and sense the temperature of the module. One ACPL736J, a 50 mV sigma delta modulator, is used together with the Chun to measure the load current. Smart gate drive optocouplers ACPL355JC can deliver 10 ampere peak of output current to drive silicon carbide module directly, as shown in the schematic on the right. It has very high working voltage of more than 2000 volt, suitable for high voltage application up to 1700 volt silicon carbide module. This smart gate driver comes with fault protection and feedback for protecting the silicon carbide during short circuit condition. The ACPL355JC has wide operating supply range from 15 to 30 volt. In this driver board, the push-pull transformer-based isolated power supplies are configured to a full rail of 21 volt. For Infineon application node AN2018-09, the silicon carbide gate voltage should be optimized according to the switching frequency. For example, the plus 80 volt and 3 volt are used for higher frequency switching and plus minus to minus 6 volt for lower frequency switching. With 10 ampere gate peak current, we can use gate resistors of less than 5 ohm to drive the silicon carbide directly. This slide shows the silicon carbide switching waveform at different silicon carbide drain current. The switching energies are tabulated with the drain current as shown, and based on the switching energies, the switching performance is on par with what is specified in the Infineon datasheet. For Infineon datasheet, the short circuit duration should be kept under 2 microseconds to prevent it from being damaged. The ACPL355JC and its short circuit protection circuits are made up of blanking, resistor, capacitors, and diode are shown in the green boxes. They can be adjusted to ensure the short circuit can be completed within the 2 microsecond time. From the waveform, the short circuit current surged to 4 times the rated current of 100 ampere before being brought down to 0 ampere within 2 microseconds. The shutdown is completed softly, shown in the blue box, to minimize the silicon carbide and silicon carbide drain source voltage overshoot. Next, we look at the driving of Wolfspeed FM3 dual silicon carbide module. Two gate drivers ACPL355JC are used to drive and protect the silicon carbide power module. One ACPL-C87B isolated voltage sensor is used to sense the temperature of the module. Like the Infineon silicon carbide module, ACPL355JC is used to drive the Wolfspeed silicon carbide module directly, as shown in the schematic on the right. This slide shows the double pulse test and the silicon carbide switching waveforms. Double pulse tests are done at bus voltage of 600 volt and drain current of 100 ampere. The switching waveform are clean with DVDT recorded at more than 40 volt per nanosecond without any force triggering of the gate driver. From the double pulse test, the energies are also calculated. Based on the switching energy, the switching performance is on par with what is specified in the Wolfspeed datasheet. Per Wolfspeed, the short circuit duration should be kept under 1 microsecond to prevent it from being damaged. The ACPL 355JC short circuit protection can be adjusted to ensure the short circuit current can be brought to 0 ampere within the 1 microsecond. From the waveform, the short circuit current surged to 4 times the rated current of 100 ampere before being brought down to 0 ampere quickly within 1 microsecond. The shutdown is completed softly to minimize the silicon carbide drain source over voltage. This is a half-bridge evaluation board with two discrete STM silicon carbide MOSFET in TO274 package. Driving the silicon carbide MOSFET is a single-channel 10 ampere gate drive optocoupler ACFL3161. ACFL3161 can deliver 10 ampere peak current and is used to drive the silicon carbide directly. It has fast switching speed of less than 95 nanosecond and noise immunity DVDT of above 100 kV per microsecond. The eval board uses a full-wave voltage doubler topology for the high and low side power supplies. It is used to provide isolated power supply to the gate driver with positive rail of 18 volt and negative of 5.5. This is per recommendation from STM datasheet. The board uses two 6.8 ohm gate resistors in parallel, which equates to 7 ampere of peak sourcing and sinking current. This slide shows the evaluation board's switching performance. On the left are the switching waveform. From the waveform, the switching energies are tabulated with respect to the drain current. Based on the drain current of 50N, you can see the ACFL3161 are able to drive the silicon carbide better than what is specified in the STM datasheet. The switching energy losses of 700 microjoules and 200 microjoules are lower than what is specified in the STM datasheet. Bulk and boost conversion are also performed at 50 kHz switching frequency. The conversion are able to achieve close to 99% efficiency using the STM silicon carbide and Broadcom gate driver. This hybrid evaluation board features ACFJ3262, a 10 ampere dual channel gate drive optocoupler, and Nexperia GaN FET. Dual channel gate drive optocouplers ACFJ3262 can deliver 10 ampere peak current to drive the GaN FET directly or multiple GaN FETs in parallel. It has wide supply of 10 to 25 volt meant for FET, which is gate voltage is normally lower than IGBT. Double pulse tests are conducted with the GaN half-bridge evaluation board at a bus voltage of 500 volt and drain current of different steps to 60 ampere. The switching waveforms are clean and the DVDT recorded are more than 50 kV per microsecond without any force triggering from the gate driver. Bulk conversion is also performed at 100 kHz switching frequency. The conversion is able to achieve close to 99% efficiency using Nexperia GaN and Broadcom gate driver. Before I end my presentation, please scan the QR code or visit Broadcom reference design website for more details of the evaluation boards. In the link, there will be an email contact if you would need the design files like schematic, layout, or even request a board for testing. Once again, I'd like to thank Bodo Power for this opportunity and you for listening. Thank you. Bye-bye.